Hello everyone! Today we will learn about Mendeleev's law. This is an overview of what we will be learning today. Curious? Let's take a look.
This word map visualizes the key stage in Dmitry Mendeleev's development of the periodic table and its subsequent validation. Before Mendeleev about 63 elements were known, but there was no clear system to organize them. Chemists used various atomic weight, leading to confusion. Through Congress in 1860, this was a major international chemistry conference. A key outcome was the agreement on the standard atomic weight. This provided Mendeleev and other scientists with consistent and reliable data, which was crucial for finding patterns. Teaching general chemistry, Mendeleev was writing a textbook, Principles of Chemistry. The need to logically organize elements for his students forced him to look for a systematic way to classify them. This practically problem was a major driver for his work. The breakthrough 1869. Mendeleev famously wrote the properties of each of the 63 known elements on individual cards. He tried arranging these cards in different ways. His genius was to realize that when arranged by increasing atomic weight, the chemical properties show a repeating pattern. He published his first periodic table and formulated the periodic law. The properties of the elements are periodic functions of their atomic weights. Refinement and prediction 1869 until 1871. Mendeleev didn't stop at his first version. He refined his table, creating a more advanced version with groups and periods. Most importantly, he had the confidence to leave gaps in his table for elements he believes must exist but had not yet been discovered. Prediction confirmed 1875 until 1886. This is what made Mendeleev famous. He described the properties of missing elements in detail. The subsequent discoveries of gallium, scandium, and germanium matched his prediction almost perfectly. This was the ultimate proof of the power and accuracy of his periodic law. Initially, the reason why the law worked was unknown in the early 20th century. With the discovery of the pattern and the structure of the atom, it was understood that properties were actually a periodic function of atomic number, not atomic weight. This explained the foundation of Mendeleev's law and solidified its acceptance in science. This work map showed that Mendeleev's discovery was not a single event but a process. First, it was built on standardized data. Second, it was driven by a practical need. Third, it required creative insight. Fourth, its validity was proven by bold predictions that came true. And the fifth, it was later explained by modern atomic theory, securing its place as a fundamental law of nature.
This law states that the physical and chemical properties of the elements are periodic functions of their atomic weights. A period is a horizontal grouping of atoms. When an element has a high degree of similarity to an earlier element, the new element with a comparable qualities is put exactly beneath the earlier element to begin a new period. A column is constructed by stacking the period one on top of the other. Mendeleev's periodic table is composed of horizontal rows and vertical columns, or periods and groups. The pieces are similar but not identical. They are placed below but somewhat apart to differentiate them. Each column will be subdivided into two subcolumns, A and B, with components from the same subcolumns sharing the most similarities. Advantages: able to anticipate the property of several elements. When novel gases were identified, Mendeleev's periodic table could accommodate them that the existence of a number of elements that had not yet been discovered, like Ag boron, Ag aluminum, Ag silicon. After discovery, these elements are named scandium, gallium, and germanium. The periodic table system created by Mendeleev became an important base for the modern periodic table that we use today.
However, there are also several disadvantages of this law. First, Mendeleev's law was unable to fix the position of isotopes. Mendeleev's table itself was based on ordering elements by increasing atomic weight. Since isotopes of an element have different weight but are the same element, they would logically need to occupy the same position in the table. However, Mendeleev's system had no way to account for this. Second, it is also unable to explain why the atomic mass of some elements were in the wrong order. Mendeleev noticed that when he arranged elements in order of increasing atomic weight, their chemical properties periodically repeat. However, to make this work, he had to infer the order of a few elements based on their properties. For example, he placed tellurium before iodine, even though this violated the strict order of atomic weight. He did this because iodine properties closely resembled those of fluorine and chlorine, while tellurium properties matched selenium and sulfur. He couldn't explain why the atomic weight order was wrong for these specific pairs. And the last but not least, in the periodic table, hydrogen could not be assigned to a correct position. Hydrogen has a unique set of properties that made it difficult to place in Mendeleev's table. Like the alkali metals group 1, it has a single valence electron and can form a plus 1 ion H+. Like the halogen group 17, it is a diatomic gas H2 and can form a minus 1 ion H-, a hydride, to gain an stable electron configuration. It also has properties entirely its own, such as being the only element with no neutrons in its most common isotope. Because it shares properties with two very different groups, Mendeleev could not assign it a fixed, correct position that fully represents its behavior. After some discoveries of disadvantage, this law had a revision. We can see the result of the revision of Mendeleev's law in this era. In simple terms, the modern table is organized by proton count, not weight. This is the revision that made the periodic law perfect. Last one, its conclusion. The conclusion itself is Mendeleev's law is a long journey of an inventor who was not afraid to modernize his own theory. Okay, that's all about Mendeleev's law. Thank you guys for watching this video and see you!